Namaste student. Here we have two-dimension and three-dimension formulas. Let's recapitulate each and every formulas. So starting with the first circle. If we are provided with a radius, we can find area and circumference. Similarly for triangle, if we have the base and the height, you can apply half into base into height formula. And if sides are given, if height is not given, then you can apply Heron's formula, that is root over s into s minus a, s minus b, s minus c, where s is a semi-perimeter. That means a plus b plus c by 2. Perimeter means sum of all sides, and if we divide it, we call semi-perimeter. Now here third one is quadrilateral. If you see the quadrilateral, if one diagonal and on the diagonal, same diagonal, you can see that one height and second height, then you can apply half into diagonal length into sum of the length of the perpendicular distance drawn from the remaining two vertices. You can apply this formula. Perimeter means sum of all sides, and if different sides would be given to you, then we have different formula, but here we don't have right now. If different side given and the diagonal given, then you can apply Heron's formula 2 times and find it. Add them, you will get the area of quadrilateral. If you will get cyclic quadrilateral, special case, then you can see here we can apply Heron's formula. Not exactly it is a Heron's formula, because Heron's formula exists for triangle, but you can see that if it is a cyclic quadrilateral, then we can apply this formula. But you can see the difference between your side, this one triangle, here s is extra, but there is no s. After that you can find it here, the s minus a, s minus b, s minus c, s minus d, where s equals to semi perimeter of quadrilateral, and the perimeter means sum of all sides. Okay, now we'll see in details for triangle and quadrilateral. Let's see, in a quadrilateral you can see first is square. We know that area of a square is side into side and perimeter 4 into side. Here a represent as side. Rectangle, length into breadth. Perimeter 2 into L plus B, that means 2 into length plus breadth. If we go for parallelogram, so you can see here, if base and the height would be provided, then you can apply this formula, that is base into height. And if width will be given to you, then you can apply 2 into base plus width. You can apply this one for perimeter of parallelogram. Now rhombus, if two diagonal would be given, then you can apply simply this formula, that is half into diagonal 1 into diagonal 2. Now if side would be given, then you can use 4 into side for perimeter, and if diagonal would be given, then you can apply 2 into root over diagonal 1 square plus diagonal 2 square to get the perimeter. Okay, now if we'll enter into the trapezium, you can see that these are parallel side, b, length b and length a parallel side, and these two are non-parallel side, and here you are getting one height. You can apply this formula, that is half into sum of parallel side into height, if parallel side and distance between them would be given to you. And if all side would be given and distance would not be provided to you, then you can apply this formula, a plus b by a minus b root over s into s minus a plus b, s minus c, s minus d, where s equals to a minus b plus c plus d. Be careful, this one. Okay, apply this one, substitute the value, you'll get the area of trapezium when different sides would be given to you, and perimeter sum of all sides. Now we'll enter into triangle. You can see the triangle, already we have seen for scalene triangle, when side would be given to you, you can apply Heron's formula, and for isosceles triangle, you can see there is a formula that is half into b into root over a square minus b square by 4. Here b represent base and a represent equal side. You can apply, you will get the area. And to get a height means this one, this is perpendicular distance from the vertex. So this is your formula, a square minus b square by 4 inside part, you can see here. And if you'll see, compare this one, half into base into height. So here the height is this part. So once you get the height, you can apply this formula and you will get this formula. Now isosceles trapezium sum of all sides, that means a plus b. So 2a we are getting plus b. Third one, equilateral triangle, that means root over 4 into side square. For height, root over 2 into a. So if we'll again see the half into base into height, so here base half into base is a and height is root over 2a, that means 2 we are getting root of 4a square. And perimeter, that means 3 into side, all are equal, that's why we are multiplying here. Next one is right angle triangle, that means here we can apply this formula, half into base into height. And if we see the right angle triangle, then we have one theorem, that is h square equals to p square plus b square. The p means perpendicular, b means base, and the h means hypotenuse. So now sum of all sides here we have. Now if we'll see in the higher classes, then if angle would be given to you and the side would be given, then there is a different formula, that is half into a into b. See, if we'll take a and b, then opposite including the angle side a and side b is what, c. So your answer will be half into a into b into sine c. Now if you go for this two, c into b, then your answer will be area of triangle ABC is what, half into c into b into sine a. So if you apply this formula, and for this also if you apply, you will get the area of triangle. If one angle and what two side included angle would be given to you, then you can apply this formula and will get the answer. You don't need extra side also. Okay, now we'll see three-dimension figures formula, which is very much important for our syllabus. So here the first one is cube. For cube we can see that 4 into side. How? If you see, if you break this cube in a net form, you can see here the cube would be look like this. So 1 2 3 4 5 6 face, as it is not a square, but if you go for the cuboid you can see that, but right now you think it as a square. So you can see this is your a square. We know that area of a square is side square. So a square, a square, a square, 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 and a square. So if we'll take cube and LSA means lateral surface area, that means excluding base. So if you see the excluding base, this will be the top and this will be in the bottom. This will be the bottom part and this will be on the top part. If we take it like this, that means excluding this part, if you add rest, you will get here a square plus a square plus a square plus a square, and get here 4a square. Similarly, for total surface area without excluding the base area, you will get 6a square. So you will get here 2 extra a square and we'll get here 6a square. So from there we are getting. And if you look at the volume formula is there. Volume formula is base area into height. So base area into height, base area is what, square. If you take it, that is a square, and the height is also a, so you will get here a cube. Similarly, if you proceed for the cuboid, you can see here 2 into length plus breadth into height, and this formula 2 into LB plus BH plus HL, and the volume is length into breadth into height. Similarly, here we have right circular cylinder. The right circular cylinder means it should be, remember, it should be straight. That means Here this we call axis, axis, and this one is radius, must have an angle that is 90°. Then only principal axis, we call this is principal axis. Right now axis we are saying, so different distance between these two, or angle between radius and the axis must be 90°. Then we call that type of figure right circular cylinder. Similarly, if we go for the cone, and if there is a what angle between the radius and the axis is 90°, then we call right circular cone. Now, where is the difference between right circular cone or simply right, not right, simply cylinder? So if you see this figure, so you can see here the angle between the radius and angle between the radius is not same. So this type of figure is not your right circular cylinder. Okay, so our formula is based on right circular cylinder and right circular cone, and we'll focus into these two problem. Next, here we have the formula. One formula is that 2 pi RH. So how did you get this 2 pi RH? Let's recapitulate a little bit. So if we'll think it here, okay, let me take in different way. So this one, you think it this. So if we'll take this is square, so this is your length and this is will be your breadth. Now you roll it. If you roll it, you can see here you will get cylinder. If you assume it, if you roll, you will get cylinder. And if you see here, so this will be what? This will be the height. This B will be your height, and if you look at this part, this will be your length. That means if you roll, this part will be your circumference. That means length equals to circumference, and circumference means what? 2 pi r. And we know that if you open it, you can see that this is your length and this is your breadth and this is your rectangle. That means area of rectangle means length into breadth, and L is here 2 pi r, that is the circumference of a circle, and the breadth means what? Height. So here we'll represent it as h. So this is our formula 2 pi r h. And now if you'll see here, we have excluded the circle, that is pi r square, and the down also pi r square. So 2 pi r square, that means total surface area. If it will ask you curved surface area, then you need to exclude base, and if it is total surface area, you need to include base. So there are two circles, we need to multiply 2 into pi r square, and here we have the common, that is 2 pi r. If we'll take it out, you will see here h plus r. This is your total surface area formula, and this will be your what? Curved surface area. And now if you see here cylinder, if you see the cylinder properly, you can see that these are the collection of circle. Okay, collection of circle and height h. So base area is what? Pi r square. So volume formula, that is base area into height. So you apply here pi r square into h, and this is our formula pi r square h, volume of right circular cylinder. Next, if you see the cone, here we have pi r l, and here L is slant height, root over this one. If you take the cone, if you see here, this is your height and this part is your length. That is not length, we call slant height. And if you see, they are making here right angle triangle. So right angle triangle, if you see here, we know by Pythagoras theorem, that is L square equals to h square plus r square, and this will give you root over h square plus r square. Plus minus will be there, but distance never be negative, so there will be no negative. We will take only positive part, h square plus r square. Now if you look at here, we have extra. If you see here, the base is circle, so pi r square, and we have curved surface area. If you see here, you can see common pi r, L plus r. This is your total surface area of cone. And if you see, if we take here one cylinder, and if we take out from this cylinder one cone, same height, same radius, then what we're going to see, that volume of cone will be what, 1/3 of the volume of cylinder of same height and equal length. That means 1/3 pi r square h. By experimentally it has been shown. Now if you see the sphere, so sphere we have same formula, as we don't have any base in the sphere. That's why curved surface area and total surface area formula will be what, remain same, 4 pi r square. And here volume, that is 4/3 pi r cube. Hemisphere means half of the sphere. If you look at here, then your curved surface area will remain same, not same, that half of that sphere, that is 2 pi r square. But if you see here, total surface area for hemisphere, what we can see, that extra circle is there, but in a sphere there's no extra circle. That's why for CSA and LSA we have 4 pi r square, but for hemisphere we have 2 pi r square plus pi r square. That means total 3 pi r square. And the volume will be half of the sphere here, so 2/3 pi r cube. And the last one, we have hollow cylinder. So hollow cylinder look like what, just take it like this, and there's a hollow inside it. So we take a smaller r and the capital R, and if we take it out, this part you can see look like this, a ring, where this is your small r and this is your capital R. And to find the area of this part, what is pi r square minus pi r square. So this is the formula, pi you take r square minus r square. This is the area, and if we multiply here with h, base area into height, will get the volume. And here we have the volume, that is pi r square minus r square into h. And if we look at here, so you need to find surface area, that means outside of the surface and inside of the surface there will be two surface area. And outside, for outside we have capital R, and for inside we have a small r. We will going to apply that one, we'll get this one, 4 pi capital R h, not 4 pi, 2 pi r h plus 2 pi r h. So here r for capital, this is outside r, and inside r the surface area you need to find. And for total surface area, we'll get extra this part will get extra, so we'll not multiply, we'll add here. So you can see here we are adding here 2 pi r square. Okay, so this will be your hollow cylinder. Now the next one, last part of the chapter's formula, you can see here the conversion. When conversion word would be there, that means if we'll take any what we call cuboidal shape iron piece, and if we break it into small pieces and convert into, how will you going to break, melt it and convert it into sphere, you can see that volume of the solid before conversion remains same for the volume of the solid after conversion. It's a very much important. And whenever you need to find the number of smaller object, like if I'll give you the bigger laddu, and if I'll ask you to convert into, if we'll take the bigger sphere laddu, here the radius r, and if I'll ask you to break it and convert into small laddu with the r, so small r, then how many laddu we can make from the bigger laddu, then you can easily find for that type of problem number of smaller laddu, or number of laddu with the radius. Given radius will be what, surface, not surface, here volume will go for the volume the bigger object by volume of the smaller object. Now your question will arise, so why we are going to apply this one, and where we are going to apply this can be seen when the painting part would be there. Like if it would be oval would be given to you, and how much or how many brick you need to fulfill that part. In that case, number of brick you can find to construct the world. So that is very much important. The surface area of the bigger object. Remember here, for number of smaller object, the formula, general formula is what? A smaller object may be anything. Here, surface area of the bigger object by surface area of the smaller object. Similar but different concept, that is volume of bigger object by volume of smaller object. Now the volume, already we have seen, we have applied this one, base area into height. Now whenever you see 1 m square, do not take it as 100 centimeter. Why? Because 1 meter equals to 100 centimeter. That means 1 meter square means what? 1 meter into 1 meter. That means 100 centimeter into 100 centimeter. That is 10,000 centimeter square. So very much important. And similarly for this one also, 1 m cube equals to what? You can see here, 10 lakh centimeter cube. Now one conversion part we have, that means 1 meter cube means what? 1000 liter of anything, water or oil, any part. Similarly here, 1000 cubic centimeter equals to 1 liter. These two conversion part will going to apply for many problems. Now in hemisphere, one more thing is that in hemisphere the height and the radius will remain same. Remember this part. In a sphere, CS of sphere and TS of sphere, already we have discussed that both are equal here. And the last one, volume of cone equals to 1/3 of the volume of cylinder. If the height and the radius of the cone and cylinder are equal, then we can apply this one experimentally and we have got the answer. I hope you people have understood the formulas. Next class we're going to start a problem. Thank you.